Hi guys, it's Abdullah Khan from Mechatronics 3B, and today we're gonna talk about 2-bit comparator, what it actually is and how it works. Moving on to the slide, we can see that we have a block diagram of 2-bit comparator, and in the simple words we can say that 2-bit comparator have two inputs and it has three outputs. But on looking keenly, we can see that these two inputs, which are labeled as A and B, are further divided into two more sections. Like A is divided into two more sections, the same way B is divided into two more sections. And we can see that A is divided into A1 and A0. Same way the B is divided into the B1 and B0. So we can say that 2-bit comparator has four inputs and it has three outputs. The outputs are labeled with the arrowhead, and these arrows are labeled with GEL. What GEL stand for here is actually, for your convenience, I put GEL. We can understand easily that A is greater than B. These are the outputs we are talking about. A is greater than B, A is equal to B, and A is less than B. And now we can see how it works with the help of truth table actually. On the inputs, we can see that there are four columns: A1, A0, B1, B0. And on the output as well, we can see that there is three columns: A is greater than B, A is equal to B, and A is less than B. How now I'm gonna explain how this truth table works. When A is equal to B, we have output of 1. What I'm explaining is, when on the input side A is equal to B, A have the inputs same as the B have inputs, what we get on the output is 1. On the first row, now at this time I'm not talking about the column, I'm talking about row. On the first row, we can see that A1 is equal to 0, A0 is equal to 0, and the same way B1 is equal to 0, B0 is equal to 0. What we get on the output is, on the output, the third column, A is equal to B, shows that when both the inputs of A and B are equal, we get 1. The same way we can see when A is equal to 0 on the third row and A0 is equal to 0, B is equal to 1, B1, and B0 is equal to 0. We can see that B is greater than A. And what happens when B is greater than A? Then we get input of 1, which on the third column, which shows that A is less than B. B is greater than A is the same thing, A is less than B, so we get 1. And this is how the table works actually. And moving on to the K map, we can see the K map of the three outputs. A is greater than B, A is equal to B, and A is less than B. Now I'm gonna explain how this K map work, and how we can easily make the K map. Is on the first, A is greater than B. On the top of the table, we have 0 0 0 1 1 1 and 1 0. What we did is the same way we have on A0 and A 0 0 0 1 1 1 and 1 0. What we did is we made a table, and on the table we did is 0 0 0 1 and 1 1 and 1 0. Like in the decimal number, we can see that it is 0 1 and 3 and 2. On the last two rows, we swap that, we actually switch that rows, and the same thing happens to this. A is equal to B and A is less than B. Now we're gonna see how this table, like K map, works. In the K map, you are required to make the multiples of 2, 4, and 8. You cannot make the multiples of 6, 2, 4, and 8, and like so on. This is the rule which we follows in the K map. And what is in the box, like we can see that there are some entries which are 0 and some entries which are 1 are the given inputs, like which we are given by our instructor or anything, like working on a field or on a large project. You can see that there are sometimes we have restrictions to make, for example, take the example of a door. We have some restrictions of opening the door, like you have to open the door at this moment, like 9:45. Let us take the example of a time 9:45. So on 9:45 we make the entry of 1, and the other entry we need to open the door is 9:55. Okay, so we take that entry 1, and these are the things which are given by the instructors. You cannot like memorize it, like it depends upon the situation actually. And all the other entries, when we need to close the door shut, we put 0. We make that table 0. Okay, these are the entries which are not needed, and other entries which are needed. And on seeing the stimulation, we can see that when this table is formed, like you make the multiples and then use the boolean expressions and then reduce that things with using different common and then common factors and then multiplication and other things. When you reduce that and you make a expression, this is actually how the K maps work. I'm not gonna deep dive into that K map. I'm just giving the review how it works actually and why we needed it in our real life. Talking about real life, we get the example of K map. How we use K map in real life is like you have seen in some like restaurants there is automatic dishwash cleaner. What it actually does is when you are washing the dishes in a dishwasher, sometimes a water clog into that dishwasher. So there are sometimes timers set in that dishwasher which makes that clog unclogged by draining it and by moving it motor. So we can easily say that K-map is works on we can easily like use a K-map on time factors. These are the things which we see further when we take a deep dive into the K-map. And these are the logic gates which we use. As we can see that A and A bar, what A bar is A not, and we can we already know that what not table stands for is if you have the input of 1, it gives the output of 0, like it switches the entries. That that is one thing that not table do. And this is the logic gate in which we have a1 like a naught and a naught to a naught bar. Okay, we can see that. And then these are the some gates which are we are using in this like logic design. And now I'm gonna make everything clear to you how these things work actually by the Proteus stimulation. As you can see that on the first section, like you can divide this thing into 3 inputs, okay, like 3 outputs. A is equal to B, A is less than B, and A is greater than B. This is a circuit that is designed, okay, and it have like 4 inputs. And we can see that on the 4 inputs we have 1 1 1 1. A1 is 1, A0 is 1, B1 is 1, and B0 or B0 is 1. What is happening is when we put these inputs, A is equal to B, giving us 1 logic stat, okay, while on A is less than B stat, logic stat, we are given the output of 0, and the same thing is happening to A is greater than B. And moving on, like these are the stimulations when 0 0 is given. Like these are the multiple stimulations that you can give, and you can check, like it makes the table of 16 inputs, okay, like 16 different types of inputs. You can give it 0 1 1 1 0 0 0 0 1 1 1 1 0 1 0 1 1 1 0. These are the type of stimulations, and then these are the logic stats on the output section which they give us the output, how the things work actually. Thank you so much.